In this video, we'll see a thing called temperature equalization. Now, look at that first word, equal. What that's going to mean is two things are going to become equal. Two things are going to start different, but they're going to become equal. And then if you look at the first word here, I bet those two things are going to be temperatures. And that's right. We're going to see two things starting at different temperatures and coming to the same temperature, called equalization. That process is called that. All right, now first, just a quick reminder. This is conduction. Heat always flows from warm to cool, or hot to cold, right? Here we have Q, the heat, going from warm to cool through contact. That's conduction. Always from warm to cool, hot to cold, no exceptions. Let's try that out here. Let's say we take this warm piece of steel and we put that in this cold water. Now we just said that heat flows from warm to cool. So isn't it true that the heat's going to leave this block and go out into the water? Yes, it's true. Warm to cool, no exceptions. Starting at 20 and 80. Now what's going to happen to the temperature of the block as it loses heat? It's going to come down some, isn't it? So it came down to 15. When the heat leaves the block and goes to the water, what's going to happen to the temperature of the water? It's going to go up from 20 to 35. I think it'll stop flowing here? I don't think so. We can still go from warm to cool, can't we? So we'll go some more. This time I did 10 degrees. We lost some more heat. It went from 65 to 55. The water gained heat. It went from 35 to 45. We still have a warm to cool situation, don't we? So more will flow. Now just 3 degrees. I think we went down 3 degrees here and up 3 degrees, didn't we? Now when's this going to stop, do you think? When will heat stop flowing? I bet you figured it out. Yes, it's going to stop flowing when this kind of situation occurs. Now the change here are 2 degrees for both of them, down and up, resulting in, hey, an equal 50 on both sides, isn't it? And now, no more heat will flow, will it? Right. We've reached a situation here called thermal equilibrium, where now the temperature of the water and the block of steel are the same, and the flow of heat will stop. This whole process is called thermal equalization. But the important thing is we reach thermal equilibrium. Now I got some numbers here. What if we tried to graph those numbers? Didn't we start here at, didn't it go 80 down to 65, etc.? I've graphed here the middle block, 80, 65, and there were all the numbers. And you can see that temperature of the block coming down. This is hours over here, and this is temperature coming down. Good. By the way, here's your video code. N12, N12. All right, that's just graph the middle block, but we should also graph the water too. 20, 35, and 45, right? Well, let's see, did I do that right? 20, 35, 45, sure. So the water's getting warmer, isn't it? And didn't we see at one point at 50, didn't they come together right here? We did see that, didn't we? Equilibrium, thermal equilibrium. Temperatures came closer and closer together, and finally they were equal. And they'll still equal. They'll stay equal going over in the future because there's no more heat to exchange. At least no more heat will be exchanged, will it? It'll stay the same. So the important thing, though, is to see this graph has the two temperatures coming together, doesn't it? Right, so the first thing you can see is the temperatures do come together. Far apart, closer, 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 and closer until they're finally equal. You see anything else here that's interesting? You might note that the temperatures change more rapidly in the beginning. This curve is steeper here, isn't it, than it is down here? Down at the end, when they get close, they don't change very rapidly anymore. You'll see a more rapid change both in the metal block cooling down and the water warming up in the beginning. Then it slows down, but they do eventually meet in the middle, don't they? Somewhere in the middle, at a temperature called thermal equilibrium. These are other graphs of thermal equilibrium, and you'll see one of these on the MCAS test. They'll ask you to pick out which graph shows how temperatures change when, say, you put something hot and something cold. You'll see something like this, and it comes through into the middle, doesn't it? Here into the middle, always here. I've noted here that the lines don't need to meet right in the middle. It could be that the warming is greater than the cooling. It could come together somewhere else, depending on the chemistry of the materials involved. But they will come together somewhere, won't they? At some equilibrium temperature. Yes. And that's about it. This is your graph of thermal equalization, reaching thermal equilibrium here. And I'm out of time, so that's it. Bye.